Hey, what's up? It's Jake from Nimbus DevOps, and now we're going to go over using a service to expose your app in Kubernetes. So this will include learning a little bit about services in Kubernetes, how labels and label selector objects relate to a service, and exposing an app outside of Kubernetes cluster using a service. So let's talk about services for a second. So the Kubernetes pods are, you know, they're not perfect. Things happen. They have a life cycle. Things die, whether you version them or they just die naturally because of whatever reason. And pods also can get lost. So you might want something like a replica set, which would dynamically drive the cluster back to the desired state using the new pods and just using that to keep your application running. So there's other cases where you'd have like multiple replicas of something that like processes information, images, whatever. And the replicas should be exchangeable. The front end system shouldn't really care about what back end replicas are using or if a pod is lost or whatever. The way that uh, Kelsey Hightower described it in the Kubernetes documentary was, think of it like a post office. Like when you take your package to the post office, you don't care how it gets there. If a truck breaks down, if a plane gets delayed, whatever, you just care that your package gets where it's supposed to go. So it's kind of like that, right? That being said, each pod in a Kubernetes cluster does have a unique IP address and even pods on the same node. So there has to be a way of automatically reconciling changes among pods so that your apps continue to function. So that's where the service comes in. So a service in Kubernetes is an abstraction that defines a logical set of pods and a policy by which to access them. And services enable loose coupling between dependent pods and are defined using YAML, which is preferred, or JSON. We'll be using YAML, and all Kubernetes objects are like this. So the set of pods targeted by the service is usually determined by something called a label selector. Okay. Um, you might want to use a service without one, but we'll get into that in a second. So each pod has a unique IP, and those IPs are not exposed outside the cluster without a service. So it's all internal Kubernetes network traffic. But the service allows you your apps to receive traffic, and they can be exposed in different ways. And that way is by specifying a type in the service spec. Okay. Um, so there are a couple different kinds. You have cluster IP, which is the default, and that exposes a service on an internal IP in the cluster and makes that service only reachable from within the cluster. Then you have node port, which exposes the service on the same port of each selected node in the cluster using network address translation. And that makes the service accessible from outside the cluster using like whatever the node IP is and then the node port, which is a superset of cluster IP. And then there's two more. You have a load balancer and external name. So the load balancer creates an external load balancer in the current, wherever you're hosted in the cloud or whatever, and it assigns a fixed external IP to the service, which is a superset of the node port. Then you have the external name, which maps the service to the contents of the external name field, like, you know, stuff.example.com or whatever, and returns a CNAME record with its value. So there's no proxying of any kind set up, and it requires that you're using version 1.7 or higher of kubedns or a core DNS version of 0.0.0.8 or higher, because the older versions didn't do this. You can check out the source IP information or how to connect apps to services on the Kubernetes documentation. But that's pretty much it for services. But then you get down to labels. So the service routes traffic across a set of pods. And the services are an abstraction that allow pods to die and replicate in Kubernetes without impacting your app, right? You get like an endpoint, it points to the endpoint, and you don't care what happens behind that. So discovery and routing among dependent pods, like a front end and back end component in an app, is handled by the Kubernetes service. And services match a set of pods using labels and selectors, which is a grouping primitive that allows logical operation on objects in Kubernetes. And the labels are key value pairs attached to objects that can be used in any number of ways. such as designating objects as dev, test, prod, embedding version tags, classifying an object using a tag, etc., etc. So I'll give you, this is a Kubernetes, from the Kubernetes documentation. Here's an image that you can look at, and you can see that um, we have a deployment in here, right? And there's a replica set for an app that runs on the back end. And that we have this app A and app B, and this selector is selected app equals A, right? And then there's a service that runs, and it knows where to go for those apps. Um, and by using labels like this, you can kind of group things together. So labels can be attached to objects at creation time. You can attach them, after they've been created. They can be edited at any time, and that's pretty much the long and short of labels and with services. So let's check out how we might expose this Kubernetes app outside my cluster using the kubectl expose command. So that's the new command we're going to be learning. You'll be able to view and apply the labels and objects to objects with this with a different command, which is kube controlled label. So we'll be using expose and label. So let's go ahead and clear the terminal and make sure you go through all my other tutorials so you have everything started. And let's just start out with a simple, let's get our pods. Okay, and I still got this bootcamp pod running. And then let's check out our services. We shouldn't have any because they didn't make any. Well, we have one, sorry, and that's the cluster IP. So this service is created by default when, in this case, Minikube starts a cluster. So if we want to make a new service and expose it, we have to use the expose command with a node port as a parameter. Now in Minikube, you can't use the load balancer yet, but that might change in the future if they update it. So we're going to use the expose command, and we're going to expose our deployment slash Kubernetes bootcamp, and the type is going to be, like I said, a node port, and then our port is going to be just 8080. So we have kube control expose deployment Kubernetes bootcamp, type is node port, and the port is 8080. So now we see that there's a service that has been created and it has been exposed. So let's try getting our services again. And now we can see we have two. We have the cluster IP, and now we also have a node port, and it shows you the port and what it's forwarding to. So to find out what port was opened externally by the node port option, you can actually use the describe command to get more information. So let's describe our, services, and then Kubernetes bootcamp. And we can see here the node port, it says unset, and then there's this guy right here. So what we can do, instead of typing this command and looking at it and doing all this other stuff, we can set an environment variable. So let's go ahead and export node underscore port in our local environment, and we'll create a variable. And the object inside of here will be a command that runs kubectl get services slash Kubernetes dash bootcamp dash O, and then we're going to say go dash template is going to be equal to, and then in parentheses, index dot spec dot ports 0 dot node port. And I pulled this out of the documentation, so if you're wondering how I know this, it's not because I'm smart. Okay, I think I have one too many. Oh, it's expecting another one. Let me try this again. Oh, there we go. Let's see here. What did I do wrong last time? Oh, I had too many right here. Okay. So now we can test that the app is exposed, and we can grab this node port, whatever it is, and just curl in whatever $minikube IP is, and then we'll grab the node underscore port, which is basically curl IP on this port. And that's how you would do that. So in my case, I don't get a response So what I can do is we can use the Kubernetes Bootcamp terminal, because again, there's some networking things that I do not have set up because there's some things that are unset. And we can curl this, and what we should get is a hello Kubernetes Bootcamp, whatever, running on whatever your node is, and then the version. So since this isn't working in here, I might be able to try this elsewhere, because this might have been just broken from the beginning. So let me share this with you here. Can I move this? Not really. Let me do this. There we go. All right, so I ran all the same commands. I got my pods, my services. Here we are. There's my cluster IP, my node port. I described the service for Bootcamp, pulled it in, and then said, hey, give me the node, set the node. Well, I probably didn't do this part, is what I didn't do. And I got my node port, and then I curled that node port. So let me try doing this. We're going to see if this works. So what I want to do is I just want to add in one last command before we curl, and that's that I want to echo this node port in the node port and then try it. And it probably still won't work because, like I said, my environment is set up a little bit differently, but we'll see. So, but at least I got it to work over here in this virtual terminal. To give you an example of how that works. So regardless of whatever's broken on my computer right now, because I had some extra credit stuff when I wasn't making this video. So I'll probably just go through and delete everything and then recreate it and then go back through and make sure it works. But just to show you how that works, so you get the Hello Kubernetes Bootcamp running on, here's my node, and there's the version. So there you go. If you've got any other questions about exposing an app, just remember that you have to do that with a service. And if you don't have any other questions, then what I'll do is I'm going to move on and go into using labels. And I should be able to do this even though this isn't technically broken right now. And you can do kube control describe deployment and get my deployment description. And you can see the name of the label here. So if you look through here, let's go labels, app equals Kubernetes bootcamp. So we can use this label to query the list of pods. And we can use kube control get pods command with a -l parameter followed by the label name. So instead of saying, maybe you have a bunch of pods, in this case I have one, so it's pretty easy. So if I do kube control get pods, you can see that. But if I filter by label and then I say app equals Kubernetes bootcamp, if I had a bunch of pods, it would just return the one with that name. You can do the same thing with the existing services. So if I said kube control get services and then with a label, so this is the equivalent in the cloud of like tagging Kubernetes bootcamp, and I get my service. So you can get the name of the pod, store it in the pod name variable like I did before. And then you can apply a new label if you wanted to. And you could say kube control, kube control label. So that's the third new command. And we'll say pods. And then I'm just going to take my pod name variable, and you can type it out if you wanted to. Version equals v1. And now it says it's labeled. So now what happens? Well, let's do a kube control describe pods, and I could put the pod name in, but I only have one. So, and you can see here and look at the labels, and I still have my app equals Kubernetes bootcamp, but I now have version equals v1. So you're basically just attaching key value pairs as a label or a tag, if you will, to be able to organize them, find them, group them, perform operations on groups of pods and things like that. And you could also do it by the new label that I have, which was a lot easier to type, right? Kube control get pods and then -l, and then I'll just say version equals v1. And we can see I pull up the same node using the label selector with version instead of app, because v1 is a lot easier to type than Kubernetes bootcamp. So if I want to clean up now, I can run kube control delete service, and then you guessed it, -L, and I could do app-kubernetes-bootcamp, but I also could do version equals v1. Now that might be kind of dangerous because if you deleted that, then you might have other pods that are all, or services that are all using different versions, and you would basically delete anything that was version 1. Let me spell Kubernetes wrong. Kubernetes. There we go. And it's been deleted. So now if I get my services, we'll see that my other one is gone, and I'm just left with my cluster IP, and my curl command wasn't working before. But if I was to delete this in my other terminal, for example, um, here I'll show you. I'll do it in another terminal. I deleted it and it says fail to connect, connection refused, and that's because it is now broken. So that was a little cleanup. Um, and then if you try to uh, uh, exec IT, like SSH into it or curl into it or whatever, you're going to find that the service has just no longer been exposed publicly, and you would have to access it via a proxy or via the kubectl Kubernetes API, because it's no longer publicly available. So anyways, that is how you expose an application to a public area outside of the Kubernetes internal network. And if you have any questions about labels and cleaning up, then let me know. And if not, then I'll see you in the next one.